Bookio organizes your course by the learning concepts within, and the connections between these concepts. Connections can be linear, like the order material is taught in class, and these connections run around the clock face. Or these connections can be nonlinear, like shortcuts past material you might not need to know, and these run inside the clock face. Together, these help you define personalized learning plans through the course material. After logging in, the learner chooses a course, in this case, Government 2001. She is presented with the concept plan on the left, the concept map on the right, and a header menu on top. The whole course is shown to provide the overview or context of the high-level course concepts. The learner can now start to explore the concept map. If it's her first time using Bookio, the system will recommend taking a tour through the core features of Bookio. Concepts are nested into hierarchies, here with the basic concept, which has model definitions and notation, forms of uncertainty, and other sub-concepts. In class, these concepts are taught linearly, one after the other. Initially, the system shows learning plans to all top-level concepts, coded by the color of their destination. When hovering over a concept, the concept map and the concept plan react, and a tailored learning plan directing her to maximum likelihood estimation is shown. Notice how all non-related concepts are grayed out. The concept plan tree on the left-hand side expands so that the selected concept in the learning plan is highlighted. If the user clicks on a concept, then the concept map zooms in so that the sub-concepts can be seen. If the clicked concept is a leaf and has material attached, such as videos, PDFs, or lecture slides, then all of these material segments fan out to be directly accessible. Clicking through then accesses the material. The materials in the concept map are also listed in the panel on the left, and the user can choose from this selection. If more space is needed for viewing the content, then the left-hand concept plan panel can be minified. To work towards learning a goal concept, the user first wants to learn the prerequisites. Setting solving analytically as her learning goal locks the learning plan, then lets her see what she has to do within this learning plan and allows her to walk towards her goal step by step. Notice she has to learn some parts from basics, some from theories of inference, but that she can skip the finite properties concept shown here. If a user decides that she is ready to learn the concept, she can start the lecture simply by clicking it. If she prefers using Wikipedia, she can switch over to that source with a single click. After learning, she marks the concept as understood. This information is then taken into account when generating new learning plans in the future to skip over understood content. If a student knows she wants to learn about likelihood ratio, for instance, she can enter that topic into the search bar and the map will take her there. She can then mark this concept as a goal and explore the neighborhood concepts and plan leading to this goal concept. Our content creator starts a new course and is presented with a map that shows one initial concept. She can rename this concept, then add more at the same hierarchy level. For each high-level concept, she can add sub-concepts to extend the hierarchy. She then adds learning material to each concept. These can be videos, PDFs, LTIs, or lectures. Dependencies between concepts are added by simply clicking a directed link between concepts. Learning plans are then automatically generated through these dependencies. The concept map design is also able to show quantitative data as overlays, such as showing aggregate student progress. The design also supports applications, collections of concepts taken from around the course which allow students to accomplish a common real-world task. In conclusion, Bookio attempts to use interactive visualization to combine an overview of a course via a concept map with the ability to dynamically visualize personalized, nonlinear learning plans. Thank you.